Alright, this is the third time I've tried to make this video, so I'm sorry. It's all been handwritten already, and sorry, but the upload at my house is not healthy. It's kind of the motif right now at my house. So I'm sorry, but this is how to get through formulas 1, 2, and 3. First of all, I need you to remember there are 5 formulas that you'll want to pretty much have memorized. This is obviously all about the first 3 of them. They deal with how things move, so there are states of motion. The simplest form of motion is not motion. That makes sense, don't it? So your constant velocity is nothing. That means you're not moving. Your velocity is 0. The joke phrase I use is it's just like life. Everything adds up to nothing. So if you're not moving, that means the sum of the forces on you are nothing. That's equilibrium. If the sum of the forces is 0, then you are in equilibrium, and it's just like life. Everything adds up to nothing. Remember Newton's second law is F equals ma. If force is 0, acceleration is 0, because objects will have mass. Okay? Sometimes things move with a constant velocity that isn't 0. Just because the velocity isn't 0, that doesn't mean the forces can still add up to nothing. All right? If you have a constant velocity, then you are in equilibrium. Your forces add up to nothing. And what that means is, though, is your position is changing at a constant rate. You have a constant velocity. So if your position is changing, then we have to note a difference in your position. And we usually start with x's, meaning your position on an axis, on a horizontal axis is usually what we say things move on. Now, gravity acts in a y, obviously, and sometimes we have a z. But to start out with, we'll talk about horizontal motion. Things move on an axis. So you have an xi and an xf. I is initial. That's your starting position, your location on an axis. Your xf is your ending position. Where did you finally end up? V is obviously your velocity. That little bar over top of it means an average velocity. And a t is obviously time. So this bar as an average velocity, again, just means it's a constant velocity. It's not changing, or you're calculating an average. Now this formula, V equals d over t. Sometimes we'll put a little bar over top of that or not to mean it's a constant or average velocity. That average velocity is simply a distance over time. This is a formula that you learned, gosh, back in probably 5th grade, isn't it? V equals d over t. Please remember that formula, but what I want you to realize is, and what I will show you here in a bit, is how this formula is a fantastic formula for 5th graders, but to make it more AP Physics worthy, it looks like this, okay? Please realize that this and this are exactly the same. That's why they look different. But this formula is that one, and it's obviously the version I want you to remember is Formula 1. That's why I have it highlighted as Formula 1. But this is that. Alright? Now, what I will do is show you where this comes from. There. Remember, a velocity, again, what I just wrote is a distance divided by a time. That distance means your position is changing. And when your position changes, it happens over an interval of time. That means that the time is changing as you're moving. So that distance becomes a delta, a change in something. A change in anything is communicated as a delta, and it's calculated as pushing the minus button, final minus initial. All right, so a final minus initial. So a delta x, final minus initial, your ending location minus your starting location. All right, a delta t is the same thing. A delta anything, final minus initial. All right, final time minus initial time. This should look strikingly similar to a slope calculation because it's a slope calculation. So this is, again, how you calculate a slope, a change in a y-axis divided by a change in an x-axis. But we'll get to the x-axis and y-axis. Now, when you start moving, usually the time you start moving we'll call 0. So that'll go away. So the velocity becomes xf minus xi over t. Alright? So this, hopefully, isn't too big of a stretch to go from here to there. These two, I think, look pretty similar. But what we're going to do next is kill the fraction, because fractions were created by the devil, weren't they? So, multiply the t over vt equals xf minus xi. And then the last thing I'll do is push the plus button, move the xi over. But we usually write the xf on the left side. So that chain of logic is what gives you this formula, Formula 1. Please note the relationship between this equation and that equation, okay? They are the same. That's why they look different, all right? Please remember that. So let's pretend in our heads you're walking the hallway. I'm just making up numbers to keep it friendly. 160 feet, it takes a little over a minute. 80 seconds. What's the velocity? First thing I want you guys to do is list the things you know and looking for. So that xi, your initial position when you walk a hallway of 160 feet, it's not given explicitly as being 0, but you can tell it's going to be 0 because they don't even mention it. So your first step has to be somewhere. It's at position 0 if it's not even mentioned. Your final location is 160 feet. Velocity is the goal, and the time, again, is 80 seconds. So please start by writing the formula xf equals xi plus vt. Now what I did here was I crossed out the xi and called it 0. Alright, so crossed it out and call it 0. It doesn't, go ahead and write it, but call it what it is, which is nothing. And then, since we're solving for v, I'm going to divide the t over xf over t equals v. So please do math with letters. This step here, please do math with letters. Alright? Then substitute numbers where letters used to be and solve it. And you know it's very easy, 160 divided by 8. Alright? Now, again, sometimes they write the v with a bar over it. Sometimes I don't. I guess I get lazy at times. But usually, when we're dealing with this Formula 1, it's assumed that it's a constant velocity. It has to be, or that formula wouldn't be accurate. Sometimes they'll give you a way to calculate an average velocity, because that v with the bar on it sometimes means an average velocity. And average anything, you know, is you add up a number of numbers and divide by the number of numbers. So what I want you to remember is Formula 2 is an average velocity formula. Formula 2 is an average anything, but it happens to be a velocity. We usually simplify it. Instead of adding up a whole bunch of v's, we just say the initial plus the final divided by 2. That's an average velocity. So if you start rolling downhill, right, your initial velocity is 0. As you roll downhill, you build up to whatever your final velocity is. If I were to ask you for your average velocity as you were rolling, you would say 0 plus your VF divided by 2. So your average is half your final. Sometimes they'll say your final is twice your average. Again, that's only true if your initial is 0. So please remember Formula 2 is nothing more than an average velocity calculation, calculated by just adding up a number of numbers and dividing by the number of numbers. Okay? That's Formula 2. To get to Formula 3, what we'll do is then have our velocity change. So now we're no longer going to see a bar over top of those V's. This is going to be a change in velocity as time goes by. So this is a delta V over delta T. This should look like another slope calculation because it's another slope calculation. VF minus VI over TF minus TI. Again, your initial time is usually 0. So what I'll do is get rid of that, move that t over because fractions were created by the devil, and move the VI over. So the strategy for arriving at Formula 3 is exactly the same as the one for Formula 1. So please remember this. Your final velocity is equal to your initial velocity plus your acceleration times time, your AT. Where it's at. Alright? Alright, so for a couple more examples of this, what about your mommy drops you off at school and she floors it? She goes up 20 meters per second, 2 seconds. What's the acceleration? Again, please get in the habit of making variable lists. Your initial velocity is 0, your final is 20. The acceleration is your goal. Please get in the habit of writing the word goal next to what you're looking for rather than simply a question mark, because later on we will have things that we don't know and aren't given, but we're not looking for them. So to help distinguish between what you simply don't know and what it is you're looking for, we'll write goal for what we're looking for, question marks for things we don't know. The time is 2 seconds. So this is VF equals VI plus AT, and what I did again was simply X out the initial velocity because it was given as 0. She drops you off, so that means she stops, hopefully. Then she flips it, so her initial velocity is 0. So to calculate an acceleration, all I did was divide the time over. So again, please do math with letters like I did there, then substitute and solve it. It's very easy. Meters per second divided by a second's meter per second squared. Now what about when your mommy picks you up? She's driving 20 meters per second. She slams on her brakes, stops in 1 second. Okay? So here, the initial velocity is 20. Final now, she's stopping. The acceleration is still the goal, and the time is 1 second. So here, the difference is the final velocity is what gets X'd out as 0 instead of up there when it was the initial velocity that gets crossed out as 0. So now I have nothing. 0 equals quite something. And so what we'll do to solve for that acceleration is subtract the VI over. And so you get negative VI. Divide by t is a, and so there's your negative sign. That's where it comes from, is that algebra step. Negative 20 divided by 1 is obviously negative 20. That is the acceleration and where it comes up to be a negative number. Okay? Please, please, please get in the habit of doing these the way I just showed you in terms of making variable lists and doing math with letters, writing the formula first and doing math with letters and what have you. But anyway, that's the those are the first 3 formulas, and I know I always say don't memorize. But what you're going to need to do for this class is just those 5 formulas, which there's obviously 2 more I'll show you. You're going to need to pretty much know where those are, okay? But anyway, sorry I can't be there. Hey. Yay, physics.